why did you leave Nvidia at this point? I mean, of course, at this hype cycle where people want to work at Nvidia, you leaving was really shocking.
But ultimately, I think that I personally have had pretty serious.
So what is the future you think of AI is now? If we can go on the route of making things more efficient, why would we need more expensive GPUs? So hello everyone, it's so nice to have Subhan back on our YouTube channel. His story is so inspiring, starting with PhD in civil engineering to becoming AI lead at Nvidia, partnering with Snowflake, solving the cloud problem as well as the data problem as well as the hardware problem for Nvidia and Snowflake. We'll get to know his journey, and his example is about how context changes everything. A data engineer at any other company might be doing the same work, but the impact at Nvidia is the highest. So that's why I want to break down how this context of working at Nvidia changed your life, making you who you are today, solving the data problem, solving the hardware problem, and most importantly, of course, the future of AI and GPUs. So hi, Subhan, can you please introduce yourself?
Sure. Thanks for having me again, Harnoor. My name is Subhan Ali, and I've had a background that spans getting a PhD in engineering, working in data science and machine learning and product management and business development throughout the tech industry, including my most recent time at Nvidia. And really great to be here and been in the Bay Area and California a long time.
I first want to know your journey at Nvidia before leaving Nvidia. So you first of all came from PhD in civil engineering. How did you end up at Nvidia?
Sure. So basically, all my academic degrees, bachelor's, master's, and PhD, are all in civil engineering. And what happened is I ended up getting those degrees. I can go into how it happened, why it, what changed. But in that process of doing that, I realized that the construction industry kind of wasn't exactly where I wanted to build my career. I was really, when I finished grad school, was trying to figure out, well, what do I want to do next? And I looked at a number of paths. One of those paths was actually in the tech industry, and specifically around becoming a data scientist. And so what happened was, after finishing at Stanford, I did this program called Insight Data Science, which helps people with PhDs become data scientists. So I did Insight, and Insight was a great program. And then from Insight, I ended up as a data scientist at what was then called Symantec. I think now it's called Gen, which is a cybersecurity company. And specifically, I was working on the Norton cybersecurity product. I was at Symantec, basically doing business intelligence analytics. From there, I went to eBay. At eBay, I was a product manager doing trust and safety, which is really around helping people use the eBay platform kind of as it's intended, and then ultimately protecting both buyers and sellers from things that can go sideways on the eBay platform. And then I joined Nvidia from there, and I joined Nvidia in a role that was developer relations, and that means really helping to cultivate and motivate the ecosystem and the customer base around the different technologies that Nvidia makes, and then Nvidia was obviously a great experience. I went there with kind of that as my motivation, and then when I got there, I was trying to figure out. I used a product called Teradata before I joined Nvidia, which is a well-known database solution. And I was like, oh, maybe we should partner with Teradata. Found out there wasn't much happening there. And then at the same time, I started talking to a number of my partners and customers, and it turned out that pretty much all of them were using Snowflake. And it turned out that there wasn't really a good way to use Snowflake with a GPU or any NVIDIA technology for that matter. And what I ended up doing was I said, well, this seems like a really hard problem. Might as well take a crack at it. And so I did. And I really threw myself at that problem for what ended up being years, and fortunately had the support of our CEO, and then ultimately the ChatGPT moment happened, and then really the whole ecosystem, just turned on in a way, and Snowflake, really engaged and partnered with us. And then I spent the last 2 years actually working deeply across Nvidia and Snowflake.
So you brought relevant data experience to Nvidia at the right time, because it was right time and right moment. Nvidia wanted to get into cloud providers, right? I think that was the mission at the time.
No, Nvidia had already been in cloud providers.
Okay, they were already
before
there.
I joined.
Okay,
Yeah.
so you
Yes.
made a LinkedIn post about cloud platforms versus hardware. They are very difficult problems
Yes,
to solve
yes,
and very
yes,
independent.
yes.
All the data of companies is now stored in cloud.
Yes.
So how did you tackle both those problems, and what problems did you solve in both of them?
Yeah, I mean, so the LinkedIn post was actually primarily around the fact that I would say Snowflake is a data company and Nvidia is an AI company. And so that's what the post was about. And basically what that means is that data requires a specific type of mindset, and AI actually is a mindset different from a data mindset. And so when you're trying to make these two worlds meld, it's actually pretty challenging. And so there's that part of it. And then, as it relates to the cloud, I think Nvidia makes their technology available in any way, shape, or form that customers can want to take advantage of. And the cloud is simply one of the ways that happens. One of the powers of the company is that you make a technology platform, and then you make it simple, and you make it simple, but it's kind of like Lego building blocks, which is somebody can take the Lego building blocks as you intended to use them, exactly to the T. They can also actually take them apart and then put them together in a different way that might suit a different application a little bit better. So as an example, if I gave you a Lego set and you can make a spaceship with it, you can make a spaceship with the Lego, but actually you could also reconfigure them and make a car or make a bus or make something else. And that's the power of what Nvidia makes, which is it's a technology platform that is sophisticated and advanced, but when you decompose it and then you put it into different places, you're just giving people more options.
Excellent. Another example could be if you buy your own H100 or B100 GPUs, you set one kind of GPU for, let's say, training robotics. And when they are already being used for robotics, you cannot use them for other purpose. But when you're using Snowflake, Nvidia on Snowflake, you can put some of the workload at a cheaper cost into robots, some for LLMs. So it's these building blocks which gives you more use case at a cheaper cost. That's what you're saying,
yes,
right?
Yes.
Yeah. So now how did you become AI lead for Nvidia, partnering with Snowflake?
Yeah, I mean, that happened, basically what happened there is that I saw that we were not really there wasn't a whole lot happening with Snowflake. And so that job didn't actually exist. Nobody was doing it. And I kind of started working on it quite some time ago. And really it was just really 5 or 10% of my time. And I was hoping to get just a lot more interaction. And what ended up happening was I went to Snowflake's conference in 2022. I found out that there was more cooking than I may have realized. And not long after that, Snowflake, it became clear that Snowflake was building a product that is public now called Snowpark Container Services. And what that does is it allows you to use a GPU natively inside Snowflake's environment. And then not long after that, the ChatGPT moment happened. And then at that point, the partnership, the integration, the desire to integrate technology became so much larger. And so ultimately, what for me was a 5 or 10% of my time job became my entire job and more. And so really what happened was nobody was doing that job. I went and tackled it. And then when the demand manifested, I was in the perfect position to turn that into my full role.
Excellent. So what can you explain, how did you add value to Snowflake at Nvidia? Because the speed at which Nvidia has innovated is mind-blowing. Let me give you an example. Apple's conferences, Apple's WWDC and iPhone launch event are the most watched keynotes in the world on YouTube. until last year. Last year, Nvidia's GTC got more viewership than iPhone launch event, as well as for WWDC for developers. It's mind-blowing how much enthusiasm Nvidia brings. The sense of humor. I have laughed more smiled watching, a product which is only for enterprise customers. I can never afford to, I can maybe afford one H100 GPU. I would never buy it. This is not even for me. I am maybe just AI enthusiast, which, who is interested in watching. But more people watching hardware which they will never use.
The way I would frame it is, Nvidia as a company has publicly been around, since 1993. And I think people often forget that. And so what's really happened is people look at the last 2 years and think this company came out of nowhere. And it couldn't be farther from the truth. And I think if I was even, for me personally, to kind of, categorize my time in the company, it's really the pre-ChatGPT and the post-ChatGPT. And in pre-ChatGPT, when I was engaging with the market and the ecosystem, I always got comments that were kind of like, well, I don't have a server, I don't have access to chips, how are we supposed to work together? This doesn't make any sense. And people weren't even really thinking software or AI for that matter. They were kind of just thinking of it as just a simple thing that you plug into your computer. And then after that, I think everyone's mind kind of opened up and realized, oh wait, there's something here that's way bigger than what I thought before, which is this whole world of AI and the realization of what that means. I think that what happened is you think and you talk about technology, and every technology wave is different. There's obviously there was the PC revolution that happened. There was the internet bubble that happened. There was mobile that happened. There was cloud computing that happened. There's all these things, and and right now we're in this AI revolution, right? And in each one of these, there's kind of always like one company that you associate most clearly with what's going on. Definitely there's been Cisco, there's been Microsoft, there's been Apple, there's been, you associate that. And right now, when it comes to AI, it's Nvidia. And like, I think what's happened is each time, like, people's minds just open because they realize the technology can do something that they didn't see. And I think that what gets people really excited is, what does AI represent? Like, what does that mean? And we're talking, like, in all the previous ones, we were talking about either a hardware component or a technology that somebody kind of uses but doesn't necessarily interact with. And then with AI, when ChatGPT happened, people could interact with it in a very real way, and in a way that was human, or perceived to be human. And when that begins to happen, people start having a different relationship and a different perception of what the underlying technology is. And so it's interesting, like what you're saying, because it's like, yes, most end consumers will not touch an H100.
Yeah.
Right? But they all have touched ChatGPT. And for me, even personally, I found that when I joined the company, and explained to people what I did, it wasn't always obvious. Like, it kind of was like, well, we make compute that then people can train something on. And after ChatGPT, I would just simply say, do you know what ChatGPT is? And the answer is always yes. And I'm like, well, ChatGPT was trained on a bunch of compute or chips, and Nvidia makes those. And then people instantly get it.
Totally, but what an explanation. But what's the exponential value that Snowflake got during your time?
I think the way to think about this is, like, there's three parts of the AI lifecycle for, like, an end developer.
For cloud providers, yeah.
Yeah, but, like a data scientist or somebody who's building a model. So there's like data prep, there's training, and then there's inference. So these are all three critical parts of what happens, and actually you do need all three in order to do this well. And if you think about it, like, Nvidia's compute is used widely for training a model, and as well as doing inference. But there isn't, there isn't really an Nvidia product that I know of that is a massive store of data. And so Snowflake is actually a massive store of data. And so when you think about the whole life cycle, okay, well, you need the data, and then from the data you can train the model on the data, and then you can make the model good. And so the value that happens is that a lot of I don't completely know this, but like Snowflake has been most traditionally associated with like analytical workloads. And when you now make that data available to a GPU for an AI model, you're simply giving your AI model significantly more data than it had before. And in Snowflake's case, a lot of times that's enterprise data that's locked away and nobody has access to. And so the value there is actually really, really high when you can take that and now feed it into your own AI model.
Oh, so for all cloud providers, having that data accessible, it's not just accessible. Now it's easier for any consumer to use. Now people at Snowflake, Databricks, GCP, all these cloud companies, rather than using queries with SQL, they can just say at table name, give me a list of data. That could have been possible before too. But now what is more possible is tell me which data does not have, let's say, Type-C port. Which devices don't have Type-C port in my millions of data? These kind of AI queries are only possible because of generative AI. And that's incredible because I have hands-on played with it and it's mind-blowing what value it is for engineers. More data scientists are needed by cloud companies as well as for end-to-end customers. Now, I have a question. Context changes. I talked about context in the intro. Context changes everything. A data engineer at an NGO for a healthcare company might be doing the same work, but the impact they make at Nvidia and AMD and these cloud providers is way higher. So what is extra they do that helps them make a bigger impact and get a bigger paycheck? Because why can't those same data engineers, data scientists, not transition, or maybe can
transition
to a bigger value company? So what is the difference between work done at less valuable companies by AI engineers versus at high valuable companies by AI engineers?
I think the way I would think about this is like, one, what does the company do? So like generally you're talking about an issue of scale. And so usually I think the case is that the higher the valuable the company, the more scale that it has. And what does scale enable you to do? It gives you two things. So one, it means that chances are you have more actual data to use in terms of building an AI model. And then two, once that model is built, it's going to probably touch and be used by more people. And so like, I think a great example is like, what Meta is doing right now with Llama, which is, it's like they already have a significant amount of proprietary data that only they have access to. And then they are, training models and then ultimately even productizing them. But like, I think Zuckerberg has even said, it's like, one company will bring AI to 1 billion people, and he's trying to make sure that that's Meta. And so I think that's kind of one of the key real things. And ultimately, depending on what game you're playing, the scale begins to matter in terms of resources that you have and what that looks like. Obviously, with training large language models, access to compute, capital, these things become really important. And so the bigger the scale, the more that you can probably do some of these things.
So the more you do with less, more impact you make. And if you have evidence of that, that helps you in transition to these roles easily as well.
Yes.
Now, if you know the story of Compaq computers in 1984, they gave competition to IBM by reverse engineering IBM computers. I'm not talking about any hardware companies now, AMD, Nvidia, but that is happening less in the last 3 years at least. Earlier, a new company with chips, similar chips, copied chips would come and give really tough competition to IBM, Intel, not Intel, but at least IBM. That was remarkable. If you have seen the show as well, there's on that. So do you think, is that possible these days?
It depends on specifically what you're trying to do. I think that like GPUs, CPUs, alternative accelerators are out there. Like the way to think about it is like, one, what's the workload that each of those can run? And then two, like what's the complexity of like what went into making it. And so I think those are just different, questions to think about and ask. I think when it comes to CPUs, like obviously there's been a lot of, obviously there's x86, there's ARM, there's been competition in this space for quite some time, and then with accelerator chips, it appears to be a slightly different story, but ultimately the market is kind of broken down in different ways. Obviously, there's Nvidia GPUs, there's other types of GPUs, and then there's also other types of accelerators. And so all of these, and there's pros and cons to each one. So like for example, if you're using an accelerator that is made by a cloud provider, then I believe all of them now actually do make their own accelerator chips. Now, that's all great, but one of the caveats that comes with that is that you have to be using that cloud provider to use that accelerator. So in other words, if you want to use a TPU with Google, then you have to be using Google Cloud.
GCP, you have to use
exactly. You can't. There's no other way to do it, right? Same thing goes with Azure. Same thing goes with AWS. They have the same thing. And so, it's a very different approach in terms of how to think about it, and then what that means for usage.
Oh, so that's the moat companies like Nvidia and AMD have, that they don't restrict you on a cloud provider. They give you the freedom, more freedom, and especially an ability to interact with low-level code with CUDA, or I think it's another term in Nickel. Yeah, have you heard about Nickel,
yes,
right?
Yes, yes.
So Nickel and CUDA are these are the libraries which allow you to interact with low level, and you don't have to learn. But DeepSeek showed us you didn't need to actually learn CUDA. You could go even a level lower, and they did it because of geopolitical tensions, and they were not allowed to use CUDA. Maybe the GPU they used was smuggled. I saw by Patel,
Dylan Patel.
Dylan Patel.
Yes,
okay.
yes,
So
yes.
Dylan Patel said that he said $1 billion total, including research, was spent. His theory is $1 billion was spent to train and deliver DeepSeek.
Yes.
So, but they quoted $5 million to bring the stock market down, or just to show off and prove their research. So my question is, how do you think, your personal opinion, when you realize that a layer below CUDA was discovered and used? Because necessity is the mother of invention, and they did it because they had to.
I think that I'll explain what CUDA is first, and then talk about what this means and what this doesn't mean. But the way I would think about this is CUDA's been around for quite some time. I think 2006, 2007 is when it came out. And what did CUDA do? So before that time, NVIDIA's GPUs were primarily only really used for gaming. And when CUDA was created, it effectively created this unified platform upon that was one layer abstracted away from just the pure chip that allowed much easier interaction between the developer and then the ultimate silicon that's sitting underneath. So that's what it did, and what CUDA actually really did is it laid the groundwork for a lot of advances or usage applications in scientific computing, high performance computing, just workloads that were non-gaming. It really opened the door to that in a lot of ways. And so that's the way I would think about what CUDA is and what CUDA isn't. And what I would say is this, so CUDA unequivocally makes it significantly easier for the vast majority of people to use a GPU, plain and simple.
With PyTorch, it's so easy.
Yes, and so that's what it does. And so without CUDA, the number of people that can actually use an NVIDIA GPU is really low. It's really low. And so yes, DeepSeek appears to have some people on their team that are some of those people. There are probably a handful of other places that may have people who have that skill set. Not many people have this skill set. And so I think this idea that you're gonna bypass CUDA is laughable. I think it's unrealistic because ultimately what you're really anybody who's serious about pursuing that means that they're going to have to go and hire somebody who is capable of programming at the tensor core level, and that's actually really, 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 really hard to do. It's actually hard enough today to hire somebody who's proficient in CUDA. I don't know how hard it would be to hire somebody who is not proficient in CUDA but can actually manipulate a GPU at a lower level than that.
It's extremely hard, as you said. Yeah. So I don't know how they did it. It's another remarkable thing that they achieved. I don't know how they achieved, and I want to learn from you how that level of skill set people watching this podcast can acquire as well. Breaking things down, going deeper and deeper. Is it needed? And if it's needed, how they can have better understanding? Because the level of sparsity they created. So like the ratio I saw is 8 is to 256. Basically, if it's a 256 billion parameter, it
activates 8 only.
8 only, yes. It's mind-blowing. Yes. In the US, only I think 60% was used. They use 8 out of 256 is maybe 1 out of 16.
Yes.
It's mind-blowing.
Yeah. I mean, I think that what they did two things. So one was around mixture of experts, which has been done many, many, many times. They also did something called MLA. I think it's called multi-latent attention. And what they did is that it has a lower activation energy in terms of as opposed to, a similar way to think about this is, if you and I are solving a math problem, theoretically we could use our entire brain to do that. Probably we're not going to do that. We're probably just going to use the left side of our brain, and the specific left side of our brain that's better at math than the rest of it. That's probably what we're going to do. And so what some of these models are doing now is instead of firing up every single parameter and a neuron at the same time, it's actually just activating the parts that are necessary in order to solve a particular problem.
So that's how a brain works as well?
Yes. So yes, quite similarly, yeah.
So but how can these kind of efficiency techniques can be learned by people watching this? Why it's only China doing, they copy and do things much better?
I mean, I think that, I think if you're trying to learn these skills, at the end of the day, I mean, these are pretty specialized skills that are being talked about, and they're not really easy to learn anywhere, whether it's in the U.S. or in China. And so I think that the way I would approach this is, one, I would actually understand coding just at a very basic level. So understanding how to write code, and then ultimately, but really what's happening here is it's more sophisticated than that actually. There's the hardware layer, and then there's the software layer that runs on top of that. And then what's really happening here is you have people who are particularly knowledgeable and skilled at both the hardware and the software layer. And they know how to write code that can manipulate things at the hardware layer in a way that gives them efficiencies that just are not very easy to do. And so when you're thinking and you're talking about this, there's a term that we used to use that it's okay, you're looking for somebody who is like a ninja. And people who can tune everything to the maximum at the lowest level possible, the software and the hardware. So this is a generally hard thing to do. And my advice is one is why would you need to do that? And do you need to do that? And I'd say that the answer is probably not, because what are we really talking about here? We're talking about large language models, and very few people can actually, and very few teams and companies can actually make large language models that are going to be competitive in the future. So if you're kind of at this point maybe not already in that circle, does it really matter? And the other question I would also ask that is where is value and challenge and skill going to accrue? And I think the large language model layer, there's probably going to be a handful of companies that are going to be able to really compete at that in any meaningful way. But ultimately, the specialization and the workflows that are built on top of that, that's where a lot of value is going to be created. And so the question I would just ask is do you really need to learn something at that low of a level? And is it going to matter in the future? Okay,
got it. So you're saying that if there is calculator, why learn how to multiply 2 to 8 times 587? Like if that can be solved with a calculator in 2 seconds, there's no value in learning and breaking down in your mind. So why reinvent the wheel? That's what you're trying to say, right?
Yes, that's exactly what I'm saying.
So yeah, because they did it because they had to, and the efficiency gains with not using CUDA isn't as much they did by creating sparsity. The sparsity level, I think it did not involve using a layer below CUDA, right? That could have been done with CUDA as well.
I'm not sure.
You're not sure.
Yeah.
Okay. Now, a little bit about NVIDIA. I want to learn about what technologies are your favorite. NeMo, NIMS, DGX, which you think has been the game-changing innovation or technology delivered by NVIDIA?
Yeah, I mean, the way I would think about this is like obviously NVIDIA is a platform company, and at the base layer is hardware, and that's GPUs, CPUs, and the networking that connects these things together, which is sometimes called a DPU or data processing unit. And then so there's the hardware layer, and then there's kind of the software layer that sits above that, and so those are the kind of the two ways I would think about that and look at that. I mean, I think the things that I've always been excited about is definitely the core compute. Like I think it's kind of really incredible. The one that I think is going to be really amazing and is starting to get out there and get used, but is traditionally NVIDIA has been the main product is ultimately a GPU. But NVIDIA it's publicly been announced many times by Jensen, going to be making CPUs, or the Grace CPU. And this has also been announced, but you can take a Grace CPU and a Hopper or a Blackwell GPU, and you can put it on the same system on chip. And this product is called Grace Hopper or Grace Blackwell.
So you can reuse the old technology over and over again. That's what you're saying. So
no. I mean, this is an all new product. I mean, it's like they're putting a CPU and a GPU together on the same chip.
Oh, so
yeah.
Okay. So does that also mean that people can use Hopper and Blackwell GPU on top of each other too, or no? It's just CPU and GPU together.
It's just a CPU and GPU together.
Okay.
Yeah.
So it's called
Grace Hopper.
Grace Hopper.
Yes.
So Grace Hopper is much better than Hopper itself.
No, I mean the GPU is the same. It's just that now you have the CPU and the GPU right next to each other on the same chip.
So it's more efficient.
Depending on what you're trying to do. Yes, it could be. Yeah.
Can you give an example of the application? Because we know about H100s, ChatGPT was trained on that.
I mean, basically, what does it allow you to do? What does Grace Hopper allow you to do that versus just having a Hopper GPU? Like that, that's the question, right? So the way I would think about this is a computer, like a CPU allows you to do serial processing, and a GPU allows you to do parallel processing. But what you do need is some level of coordination between the two in order to do anything, actually. So when you're using a GPU just by itself, it's training and it's doing things, but then also it actually has to send data back to the CPU. And so now when you have a CPU that's further away, you actually have to move a massive amount of data through what's probably a relatively small data pipe to the CPU, and then and the memory between the CPU and the GPU isn't even shared. So it's actually quite difficult to do this. Now, when you take a CPU and you take a GPU and you put it on the same chip, and then they have a shared memory with high-speed interconnects, you are removing a bottleneck that is actually huge. And so what this is, I actually think that the Grace Hopper and Grace Blackwell are just going to create entirely brand new use cases that we don't really completely understand yet. And so what you've seen happen is the current iteration of large language models has been around, really just using a massive amount of GPUs with extremely high interconnects all at the same time. That's basically what's been happening. But what's going to start happening when you can actually, put all of use CPUs and GPUs at the same time to do all these things, that's going to be interesting. I don't think I know the answer to that question. And then even as it relates to me and my world, which is like, it turns out that CPUs are, maybe optimized for particular workloads. So a workload that a CPU is pretty good at is data processing. So if you had a Grace Hopper chip and you've got the the Grace CPU running the data processing, and then it can move all that data instantaneously towards the GPU, where you can then train your TensorFlow PyTorch model instantaneously. I mean, this opens a whole new world of possibilities.
Mind blowing. I think another example I have is for the same scenario could be Tesla, because they do on-device inference for AI. For example, when you're driving, it's recognizing humans, cars, trucks, and it has to calculate whether to take this turn or that turn, prevent an accident. It's doing on device. And for that, efficiency matters. And to do those complex calculations, grayscale, Grace Hopper could be very useful. And what do you think is the future then? Because after DeepSeek, a lot of engineers I know are locally using AI models. You know, I can use DeepSeek R1, even 14 billion parameters, and it solves most of my coding problems. Of course, Claude is better, OpenAI is better, but like most of the daily coding problems can be solved for a beginner, mid-level engineer locally on a MacBook, or even on a basic hardware. So what is the future you think of AI is now? If we can go on the route of making things more efficient, why would we need more expensive GPUs?
So I think that when you're using the compute running the model on your computer, that's just inference. So that's not the model being trained on your computer. So I think, but to answer your question, I mean, a lot of the large language models that have been being trained, those are that's for training that's happening across, multiple different GPUs, simultaneously at the same time, usually in a data center. That's what's happening there. And but yeah, I mean, where do things end up? Like, what does the future look like? I mean, I think that we're going to have just a lot more optionality in terms of what things look like. So I think one of the big things about DeepSeek was that the model was open source. And what does open source means? Well, it means you can download it and put it on your computer. Right? And I think that I've seen statements from some very prominent SF large language model companies saying that they're rethinking their approach to not open sourcing stuff.
Yeah.
And so I think that's going to be pretty interesting, because what's that going to do? That's going to mean that, okay, yeah, they have the latest frontier model that they've trained for however many hundreds of millions of dollars or billions of dollars. But you and me as individual people can just download the weights of that model, run it on our computer, and interact with it in a meaningful way. So ultimately, I think it's just going to provide a lot more optionality and be a benefit. And I think the open source component of DeepSeek, I think, is actually huge.
Why would we need more GPUs for inference? Because I think so. Let me give an example. So Meta's AI lead Jan LeCun, he said that if we don't need enough GPUs for training, we still need for inference.
Yes.
But why? If we can all download and run it on computers, why do we need still for inference?
So, I mean, I think the way I would think about this thing is where is all the value going to accrue in terms of where inference happens? So, like, okay, are we going to have on-device inference? Yes, we probably are. But when it comes to like, and what you're talking about is the percentage of the population who is sophisticated and interested enough to actually download the model themselves and then deploy it on their software in some way, shape, or form. But when you talk about the question of, okay, like, imagine how many apps that you have on your phone. It's a lot, right? And okay, we have a lot of apps on our phone. We use them all, whatever it might be. And so imagine if there's going to be a large language model integrated into each one of those apps. Now, where's the compute running for each of those apps?
Good point.
It's probably not running on your computer, actually, on the phone. And so the question is going to become, well, okay, what are all the workflows? What are all the things that we use technology for? And where are things happening on the back end? And so when the truth is, we're still so early in terms of what this looks like. And I think if you were to like open up your phone and look at all the apps on your iPhone, you probably couldn't even identify which ones are using a GPU, if at all, or doing inference locally or in the cloud or somewhere else. And probably because they haven't really materially changed the workflow of the app yet to take advantage of that. So we're so early when it comes to like inference that I think the sky is quite frankly still the limit. And it's just we're I always say this, but like I mean, DeepSeek. What DeepSeek did is ultimately good for everybody working in the AI space. And the compute layer is going to be, I think, just fine. I'm not worried about the compute layer at all. And then, lastly, like, this history has shown over and over and over again, when you decrease the cost of something, you actually increase the overall consumption of that particular thing.
Jevons paradox.
Jevons paradox. Yeah. And so I think the exact same thing will happen here. Which is that AI is going to get cheaper and cheaper and cheaper, but that's going to make it so much easier to do more and more and more AI until eventually it's just integrated everywhere.
Totally. And you said last time as well, at Nvidia you do hard problems for a very long time. What problem you think you have solved was really hard and you're proud of?
I mean, I think the problem that I definitely played a significant role was around integrating AI and GPUs into the Snowflake environment. I think that was something that was not easy to do, and ultimately, brings AI and GPUs to the data world in a way that I think will ultimately be like a really great thing for data scientists, but also for like a lot of people that use the products that this will create. So I think that was a really difficult challenge, and that was something I'm proud of.
And why did you leave Nvidia at this point? I mean, of course, at this hype cycle where people want to work at Nvidia, you leaving was really shocking.
Yeah, I mean, I think Nvidia is an incredible company. It is a generational and transformational company, and I think it has an extremely bright future ahead of it. No question about it. But ultimately, I think that I personally have had pretty serious aspirations to start a company, and I think a number of things that have happened over the years have really kept me in Nvidia. But it felt to me like now was really a good time. I felt like I had accomplished something meaningful that I'd hoped to do, and that now would be a great time to go and work on something, kind of from the ground up and try to make that a reality. And I think, ultimately everything's kind of like the long game. And I think if you want to build a company, it's a long game. And Nvidia is a great example. It's the ultimate long game company. It's been around for 32 years, from 1993 up until now. And and so I think that when you can get working on something sooner than later, the network effects, the ability to compound, the advantages that you create for yourself are just really great. And so I think now is kind of the perfect time to go and make that happen.
Amazing. And what is your next venture? Can you share about your next startup? What are you going to work on?
Yeah, I mean, what I'm really thinking about is the intersection of data, big data, and AI. This is an area that is still, I think, relatively early, but the quote unquote, like the way I would think about it is like, what does the data layer, the data storage, the data warehouse look like for this era of generative AI and large language models? And what does the data store look like when you have multimodal data? What does that mean? That means audio, video, documents, text, tabular data, structured, unstructured, everything. What does it look like when you can actually store that in one centralized place? And it doesn't really appear that like that exact solution exists. And so, being able to build something that allows that, the benefits of all this multimodal data to be used for AI, I think that could be something that is really transformational.
So have you started working on it already? So my question here is like, how far are you in your startup?
I'm still quite early. So yeah, I'm still quite early.
So what formula you follow? Like, Peter Thiel, when he wrote his book, he mentions 7 questions to ask yourself when you want to create a company, such as the monopoly question. Will you start off with a large share of a small market or a small share of a big market? These kind of questions. Did you consider asking, or what formula you follow?
I mean, I think, yeah, I'm familiar with the Peter Thiel framework. And I think that I didn't follow that one. I think what I followed is like, what unique insight do you have, and what do you know that other people are missing, like that's open in the world, but like someone else saw it but didn't think anything about it. And I think that what I did with Snowflake was kind of exactly that, which is a lot of people saw this problem, but nobody stopped to think about it and figure out, well, how do I solve this problem? And so I think that ultimately the ideas that went out are ideas that are differentiated, and that the people who are pushing them have a deep and unique insight that's just different from the rest of the world. And so that's kind of my intuition in terms of how I've thought about this. I haven't done a detailed TAM analysis yet, but I'm sure I will. So.
Awesome. Yeah. Thank you so much, Subhan. It was wonderful talking to you. Great insights, learned a lot. I hope this video helps a lot. I think one question I would ask you again. So if you had to restart your journey getting into AI, becoming an AI lead, what would you do if you wanted to achieve with the knowledge you have?
I think that if I was to start this journey over again, I actually think that the single biggest thing I would change is I would have started it sooner. And so what does that mean? It means that I did my undergrad in civil engineering. I ended up getting a master's and a PhD in civil engineering. And then after that, I decided to switch into the tech world. And I think a part of me wishes that maybe I wish I'd done this sooner. So like maybe even after undergrad, or even if I perhaps studied a different topic in undergrad, I may have made that jump happen. Nonetheless, my advice to people is always like, if you're curious about a different path, get moving. And the reason I say this is because I think inertia and comfort are kind of the biggest things that hold people back from doing that. And I think that at the end of the day, if you're interested about a different path, like it's not going to be easy, but the sooner you start trying to do the hard things to get there, the sooner you're going to get there. And so whatever that might be, but start moving. And in general, the way I think about this is people, to the external world, if you look at a lot of things that succeed, Nvidia is a great example. It looks like it's stagnant for a long period of time. And then something changes really quickly. And then it's like stagnant again for a long period of time. And then something changes really quickly. We always look at the inflection points and I'm like, oh my God, I want that inflection point. But we forget about the 2, 3, 4, 5 years of just staying still that happened before that. And so perception and reality don't always line up. And my point is like, just get moving, start grinding, and then the inflection points will start happening.
And what tech stack would you use? I think last time you mentioned as well, you wouldn't recommend learning CUDA from scratch. PyTorch, Python framework is enough. Would you elaborate on that?
Yeah, I think the things I mentioned last time are probably Python, R, and SQL. So I think those are still relevant. The way I would think about this is, coding is changing, primarily because of what's happening in large language models. But that being said, like, large language models are not yet at the point where you could just blindly trust their output. And what does that mean? That means that you have to be able to tell when it's giving you something that you can use versus something that you can't use. And so ultimately, like the people who can use a large language model to augment their own workflow, even in a technical setting, like those are the people who are going to win. And so you can't be a person who's just going to prompt the LLM and then it gives you Python code, but you can't verify the usage of the Python code. But similarly, the person who writes Python code only without using an LLM may move slower than the person who can do both. So I'd say learning it in so much as like you can think for yourself is probably the most valuable thing you can do.
Totally. I think another example I would like to add on is in the world of AI agents. There are now hundreds of ways to make AI agents. 1 year ago, it was just use OpenAI's API key, connect some APIs, Notion, Gmail, Calendar, and make an agent. Now you have hundreds of options. And now the question The question I ask is not if I want to build an agent. The question is how and where I build an agent. Do you face that problem as well? Like there's crew AI, there is different libraries, there's browser agents. I just get confused.
Yeah, I mean, I don't think I have an answer to the question. Like, I think that right now, there's a bit of buzziness with the word agent or agentic, or it's being slapped onto everything. And so there doesn't really seem to be any sort of, structured or, way to tackle or to solve this problem. What I would recommend doing is just understanding what it is that you're trying to accomplish, and then figuring out what are the tools that can help you accomplish that. As opposed to like starting with a tool and being like, well, how do I plug this into that tool? And you could get lost really quickly.
Focus on the problem, tools will come later.
Exactly.
100%. Awesome. Thank you so much, Subhan. Learned a lot. Wishing you all the best for your next venture. Thank you again.
Perfect. Thanks, Hunter.
Pleasure. So.